All right, so 1/7 is again like 1/5 and 1/6, dealing with negative exponents. We do a lot of practice with these ones because there's different ways to go about doing them based on where the negative exponents are. So we've done some in 1/5, some in 1/6, and now in 1/7, we're going to look a little bit further into more types that have negative exponents and how we go about them. So our directions are going to still be the same. We're still just simplifying these expressions. So we're going to go through 4 examples of how we might try to simplify these. So our first example, y to the negative 3 plus x to the negative 3 over y plus x. So when we look at this one, I'm going to start off by taking each term with a negative exponent and making it into a fraction. So that'll, the y to the negative third becomes 1 over y to the third, and x to the negative 3 becomes 1 over x to the third. Now in the denominator, I have y plus x. I can just put a 1 under that so that it looks like a complex. Also, this helps remind me that my denominator of the denominator is a 1 and not a number. So from here, we now want to look for that LCD that we can multiply to each term. So I have a 1, a y to the third, and an x to the third. So x to the third, y to the third will be my LCD. So I multiply each term by x to the third, y to the third, including the 1 down here. So after we multiply, we will get y to the third to cancel on top, giving x to the third. In the second term, the x to the thirds cancel. And then on the bottom, I'm not going to distribute the x to the third, y to the third. I'm going to leave it in a factored form. That way, if I can factor the numerator, I already have my bottom done, so I can start canceling. And so that's going to be our next step. Now that we've got just an expression on top, an expression on bottom, no negatives, I'm going to try to factor what I can. So my numerator, I notice, is a difference of cubes. So I'm going to SOAP the numerator. So that'll be x plus y, and then x squared minus xy plus y squared. And then on the bottom, I'll still have my x to the third, y to the third, and my y plus x. So at this point, I'll look to see, does anything cancel? And I notice that I have x plus y and y plus x. Well, because addition, the order doesn't matter, these are the same expression. Now it's different if there was a minus sign, but because it's addition, the order isn't going to make a difference, so x plus y and y plus x can cancel each other out, meaning we are left with x squared minus xy plus y squared over x to the third, y to the third. And that would be our most simplified answer. So this one was a little different in the fact that our denominator didn't have a denominator with it. It was just a single expression, so we had to put a 1 underneath. So when that happens, just know you have to consider the 1, and you just end up multiplying that LCD to the expression that's already down there. And again, a lot of times I don't distribute. I try to leave it as in a factored form so that I can cancel things a little bit quicker and not have to undo work I just did. All right, so the next one that I wanted to go over also has a few little things in it that I want to show you. So this one is 1 plus x in parentheses to the negative 1 power. And in our other parentheses, x to the negative 3 plus 1. So in the same way as we did number 1, I want to try to get rid of the negative exponents. So this negative 1, because it's on the entire polynomial, I'm going to bring the entire polynomial 1 plus x to the bottom. And that is, then it will become to the positive 1. Now, because it's to the first power, we don't even have to write the parentheses or the 1. We just move the whole polynomial to the bottom. With what's left on top, because this is still in the numerator if we think of all of this being over 1. So this moved down. Here I'll have 1 over x to the third, and then the plus 1, I can write that over 1 just so that I can again see all my denominators. So again, down here, just like in number 1, I can put that whole expression over 1. So again, when I consider my least common denominator, I know what all the denominators of my complex fraction are. So just again to recap, if you think of this whole expression being over 1, the whole polynomial here has the negative, so the whole polynomial comes to the bottom. And then on top, this x to the negative third becomes 1 over x to the third, and then 1 just becomes 1 over 1, or stays 1 over 1. So now I can look for my LCD, which when I look, I have x to the third, 1, and 1, so I'm just going to multiply by x to the third. So each term will get multiplied by x to the third, including the denominator. So x to the third will cancel completely, leaving a 1. X to the third times 1 will give me x to the third. And on the bottom, just like the first one, I'm not going to multiply it through. I'm going to leave it in factored form. So x to the third times parentheses 1 plus x. Now I'm going to look to see, can I factor the numerator? Because my denominator is already factored. So again, I notice I have a sum of cubes because 1 to the third power is 1, and then here I have x to the third, so the cubed root would be x. So SOAP it, 1 plus x, and then 1 squared is 1, minus the product of the 2, plus the square of the last, so x squared, over x to the third times 1 plus x. So now I'm at the point where everything's factored. I look to see, does anything cancel? So 1 plus x will cancel with 1 plus x, and that's the only thing that I see that can cancel. So I copy my numerator, copy my denominator, and I box it because that's as simple as it will get. So these first two had a similar vibe to them in the sense that we had just one term on the bottom. So we were able to put that over 1 to help us with our common denominator. Okay, the next one that I'm going to do is, again, has negative exponents. So let's look at number 3. But this one actually is a little different with its negative exponents. So if we look at number 3, parentheses x plus y in parentheses to the negative third power times 2x squared plus xy minus y squared. So just like in the ones before, I'm going to treat this as if it's all over 1, so that this negative 3 that's applying to the whole polynomial, I'm going to move that whole thing to the bottom So I'll have 2x squared plus xy minus y squared all over x plus y, and now that 3 becomes positive. So after I've gotten rid of the negative exponents, when I look at this, I notice I don't have a complex fraction here, because I don't have a fraction within a fraction, or a double fraction if you want to think of it that way. So that means I don't necessarily need to do a least common denominator. So when I see this, I have a polynomial on top, and I have an already factored polynomial on the bottom. So if I just look to see, can I factor the top so that something might cancel, that might be all I need to do. So if we don't have a complex fraction, then you don't need to worry about doing least common denominator. So when we go through this, I don't have a complex, so I'm just going to jump to the factoring step. Can I factor my numerator? So if I do my double bubble, let's see, 2x times x gives me 2x squared. And now I need a y in each spot, but I need to figure out which one's negative because they need to multiply to negative y squared. But I need them to multiply back to give me a 1 in the middle. So that's a 1, that's 2. I need it to be positive 1, so if I put the negative in the first one, 2xy minus xy will give me my 1xy. And then on the bottom, that was already factored, so we can just copy it down. So when looking at this now, I have an x plus y on top, and I have 3 of them on the bottom, so I can cancel one of them with that x plus y on top. So I'm left with 2x minus y over x plus y squared. Nothing else cancels. There's your final answer. So you'll have some of these mixed in where you get rid of the negative and you just have a fraction. So then you just factor and simplify. The only time we have to do the LCD is if it's complex or if you're trying to add more than one fraction together. That's the only time we're looking for a least common denominator. All right, so I have one more that I wanted to do with you guys. Number 4. All right, so this one actually has multiple ways that you can solve it. If we stay consistent with how we've been doing it, we'll be able to get it done. And so that's what I'm going to do first, and then I'm going to show you a second way that you might be able to try it. They're about the same length, but they're just different ways to look at it that I want to show you. So we're going to start with the same way we've been doing these throughout the entire assignment. So I'm going to start by wherever I see a negative exponent, make it 1 over x to the 4th minus 16, and I'm going to put that over 1 just so that I have my common denominator. And then on the bottom I have x minus 2, and I can think of that as over 1 times, and then I'm going to turn this into 1 over x squared plus 4 over 1. So when we consider our common denominator, you might be wondering, do we have to actually FOIL these together? The answer is no. Because of the multiplication, we can still multiply our common denominator. The one thing we do want to consider when we multiply is that we only have to multiply it to one of the two, because it would give us the same thing when we FOIL it together. So when I look at this and we do our LCD, we would get x to the 4th because we want to take the higher power of x. So when I multiply x to the 4th times x to the 4th, and then over here I'm going to times this binomial by x to the 4th. So when I multiply it here, I don't need to multiply it here as well, otherwise that's actually multiplying by x to the 8th, and we only want to do x to the 4th. So we only need to distribute this to one of the two because it's multiplication down here. On top, we had to multiply it to each one because they were being subtracted. So that's really the difference on this one, is if you have a plus or minus, it has to go to each term. Down here, because it's multiplication, we just have to multiply it once into one of the polynomials. Alright, so on top, those will cancel, leaving us with a 1. I'm getting kind of low here, let me move this up. Then I'll have minus 16x to the 4th. And then down here, I still have my x minus 2. And when I multiply x to the 4th to that one polynomial, that'll cancel with 2 of them out here, giving me an x squared. And then when I distribute it to the second term in that polynomial, I'll get 4x to the 4th. So again, at this point, I've got my denominators gone, so I'm going to factor my top, and I'm also going to look to see, can I factor my denominator to make sure that I have everything as factored as possible for canceling. So let's see. My numerator, I notice that I have difference of squares. So 1 minus 4x squared and 1 plus 4x squared. And then in my denominator, in this second polynomial, I can factor out an x squared, which will give me a 1 plus 4x squared left inside. So at this point, I notice that I can cancel out 1 plus 4x squared. So when I do that, I'm left with 1 minus 4x squared over x squared times x minus 2. Now with this one, we actually can factor the numerator again. We have difference of squares again. So that means I can take my numerator, 1 plus 2x and 1 minus 2x. The reason I want to check that is because I want to be able to make sure I cancel everything that could possibly be canceled. So when I factor this, I now want to compare, does anything else cancel? And in this case, no, it doesn't. So this would be your simplified form. In factored form, this is your simplified in non-factored form. So again, on a test, I will take either answer, but you always want to try to do this step to make sure you're not missing something that could potentially cancel out. So with this one, we followed the same process as the ones we've done before. But we had some different things like a product in the denominator. So again, when you have a product, you only have to multiply the LCD to one of the binomials or one of the polynomials. And then you might have a case where you can factor more than once within a numerator or denominator. So you want to do that just to make sure you've got all your simplified parts. So I did tell you I was going to show you another way as well. So here is the other way. So I'm just going to rewrite this problem. And again, either one of these methods gets you the same end result. They're just different methods to get you there. So again, it's going to depend on what you see. So one of the ways we can start as on the same problem is, can you factor this right off the bat? So because even though this is negative, because it's an even number, it's a difference of squares on top. So how we would factor it would be the same. We would take x to the negative 2 plus 4 times x to the negative 2 minus 4. So as long as when you multiply these back together, you get x to the negative 4th, you can have negative exponents and factor with them. Your denominator doesn't have anything that can factor, so we can just copy it down as it is. Now, one of the things by factoring first is that we are actually able to cancel out the x to the negative 2 plus 4 on top and bottom right away. So what we end up getting is x to the negative 2 minus 4 over x minus 2. So we still are going to have a complex fraction that will have to get rid of negatives. It's just we're making it smaller and we're reducing it at the start as opposed to at the end. So if we keep going now with how we did every other problem, so make this 1 over x squared, put the 4 over 1, and then the x minus 2 is all over 1. So we would have our LCD, which is x squared. So our x squared is already reduced as well. So here I'm going to multiply everything by x squared, my LCD. So x squared will cancel, and I'm left with 1 minus 4x squared. And then in the bottom, I'm going to leave it in factored form. And again, I can check it by factoring it. So 1 plus 2x on top, 1 minus 2x, but again, nothing's going to cancel. And you can see we've reached the exact same answer. It's just where we did our reducing was a little different. So either way you want to go about these problems is fine by me. Just know that if you notice something like this where you can factor it, you can try doing that because it might help you get a smaller least common denominator and have maybe a more simple looking complex fraction later in your problem. So both methods work. You can choose the one you want to use. But I wanted to show you that second one just in case you wanted to try that for future problems.